This conference will now be recorded.
So, Elaine, I was sick last week, and I know you went over to TCG flow.
Yes, that's right. And well, I guess, did we record it? We recorded it, right?
Yeah, I'll catch up on it. But I see this morning you started by opening up the USB authentication spec.
I have, yes. All right, but so last week we went through the root of trust in the TCG world, and that was informative.
Yeah.
So, yeah. Oh, okay. All right. So I've been working on the protocols. I decided to start with one. You know, we have so many protocols we have to worry about in our spec. So I started with one that we all have referenced, which is the USB 3 authentication protocol. And what I'm going to do is go through that just briefly and then move on to a TCG one for enrollment. One of my colleagues here in IBM Research is the spec editor for TPM 2.0 spec and 1.2 spec also. And he said that there were lots of nuances to the enrollment protocol. So we've gone, he gave me a document, which is now, he just put it up on SourceForge. It's nothing secret. It's something that's anybody can see. And it brings up some interesting questions that I want to pose to this group, because
are you going to share the link for that doc? Or
I will absolutely do that. In fact, let me see if I can go grab it now and put it in the chat room. I haven't seen it from SourceForge. He just gave it to me. Let's see. Chat. Go down here. All right, let's try that. Do you see that link?
Yep.
Yes, we do.
Yep. Excellent. Okay. Good. All right. So I haven't gone there yet, but anyway, you'll see where I got the stuff from. All right. So first thing is, in going through, this is the protocol, the authentication sequence in the USB 3 spec. And essentially what it does, so the initiator here says, tell me some digests of your certificates, the certificates you have. And the responder says, okay, here are my digests. So that's pretty easy. That step is essentially a performance step, I would say, which says, have I already seen these? Do I already know what they are? If I've seen them before, I don't have to worry about them because, you know, I know what they are and that's all, everything's good. But if not, then it says, well, give me your, well, you still have to do this. You get your you ask the responder, give me your certificates. It responds with its certificates. Hang on just a second.
Is it architected as to what those certificates are? I mean, is it just any arbitrary number of them that there could be? I mean, or what are those certificates?
There's a limited number of them. I think it's 8.
Yeah. Correct, Elaine. You can have up to eight certificates. They call them slots where the certificates go into.
Yeah.
Yeah, it's a chain, of course. The first one being the root of the chain, or the one that's the beginning of the chain, which itself will be linked to some CA somewhere. Okay. Oh gosh, where are we? Where did we leave? Okay, so it looks at all the certificates in the chain. Why are we getting another certificate response? Sorry. Oh, it's getting the certificates one at a time, right? It says, okay, how many do you have? And then it gets all the certificates. And then it has to verify all of the certificates to make sure that they, the initial one at the very beginning is linked to a CA, and that the subsequent ones are linked to the beginning ones, you know, in a chain. So it has to go through all of that. And so this, yes?
There's a provision depth of 8, I believe, but you don't have to have all 8 slots populated.
Right.
That's
right.
correct.
It's
Yes.
max of 8.
Max of 8, yes.
So it provides a method of walking the certificate chain to verify signatures on each certificate to get back to a trusted CA,
Yes.
essentially.
Yeah, and it clearly takes into account that there are limited resources here, right? Because the first step, giving digests, gives you a shortcut so that you don't have to do a lot of validity if you know everything in advance and your hashes check out. You don't have to do anything more if you've already done it. And then you can get your certificates one at a time. So it's not just backing up the truck and dumping everything on on either side of the request. The last step is essentially a challenge that says, okay, here's a random number, here's a nonce, and the responder has to, I think it's sign it. I don't know if it's sign it or encrypt it, but I think it's sign.
They sign it. Yeah, they sign it.
Yeah. Okay, and then it sends it back to the initiator that can verify it because it had the certificate that it with public key to match that. All right, so now one of the there's 2 assumptions here. One is that the slots or this device is local. I think that it assumes that it's in the same system, yes? I mean, it's a USB, right? You put it in there and it's inside your system. So your initiator, the fact that this responder responds, you don't have to worry about this responder being off on the internet somewhere else.
Yeah, I would think though it depends. So if you separate the flow from the protocol that's carrying the payload, could it be remote?
Well, that's why I brought up this other thing. So let's go through that and we'll decide together.
Okay.
All right. So let me switch windows if I can navigate over there. Oh, shucks. All right, here we go. Let's see. I am going
But
to go.
it could very well be remote. I don't think there's anything specific about the protocol to say that it has to be local.
All right, let's go through this now. Let's see. Can you see? I don't know what you can see.
We can see the screen with some black and TPM enrollment protocol.
All right, just the protocol version with the diagram, or do you see text next to it too?
We just see the text excerpts from the TPM-based enrollment protocol, goals, attack model.
All right, so you can't see the protocol itself, so I'll have to switch back and forth. All right, so this protocol, this TPM-based enrollment protocol, is one that is used when you have, I'll give the scenario. You've got a server, it has a TPM in it, and externally, you want to record what TPM is in your system to an external, a server, for example, that's an attestation server that's collecting attestations from this system. So it may be some security event modeling, monitoring system. It can be, a whitelist monitoring, whatever it is. It's assuming that you've got to go through a registration step to record the public key, the attestation key, public key of the TPM. And it needs to know, so your external system wants to know who is it going to be talking to? Are they real TPMs? You know, it may have a data center full of systems with TPMs in them, and it needs to know which ones it's talking to and which specific public keys are associated with which TPM. Okay, so the goal is I've got this TPM out in the wilderness, and I want to talk to it to determine what its attestation public key is. Everybody with me?
Mm-hmm.
All right. So as an attacker, we as attackers want to convince the server. We want to lie to the server. We want to say, I am a real TPM. I have this attestation key, and you should believe me because, you know, I look like a TPM. So just take my word for it. I really am a TPM, so record my public key. And then the problem is, of course, if it mounts this attack, if it's successful, then everything that's going on between the outside server, the attestation server, and this TPM is, of course, vulnerable. So first question that comes up in my mind is, do we agree in our world, in the device world, our device is going to have a private half of its attestation key? We agree it has to be protected. So I went back to Joe's attack scenarios document, and it did say that we needed to, we did not want our private key to be compromised. But I just wanted folks to comment on that to make sure that we're all on the same page. Any thoughts?
Yes,
Yeah.
we're on the same page.
Yeah, I would agree. We don't want their private keys to get compromised. That would not be good.
Okay. So if we don't want their keys to be compromised, then we also don't want an attacker to have full control of the private key. So we don't want it to be able to forge an attestation.
Yeah.
That's correct.
All right. So the blue and gray and black here writing is, my colleague's writing is in black. This was his original document. And I tried to translate this into our world in blue. So that's why it kind of looks like it's redundant or a repeat. So in our world, our device wants to convince the verifier that it really is that it's a valid device. All right. So moving on, in our world, the platform trusts itself, but it doesn't trust the device or the device firmware. It has to be, it's going to be gathering attestation values from the devices, but it doesn't trust them. So in order to evaluate them, it's going to have some root of trust in the device that it does trust. Okay. So the platform has to start off with some kind of certificate from the device vendor, so it knows to link the device to that vendor. So if it's, you know, one vendor's adapter, it's got to have the root CA for that adapter, or it's got to be pre-provisioned with those, and it has to be, or it has to be given them on the fly, but for whatever reason, it's got to ultimately have the root certificates for the vendors, however it gets them. And those are really the root of trust in this enrollment process. Okay?
Yep.
Still with me?
Yeah, still following.
All right. And let's see.
What is that bell?
Sorry, it's dings in my phone. So
As it serves as a reminder.
No, it's texts that are coming in that I forgot to turn off.
Oh, I see.
All right. So I'm using again Ken's description. In our case, we do not protect against it. In this, if we use this, when we review this protocol, the protocol does not protect against a device lying about its device ID, or that it's a device. It assumes that this device is okay to be provisioned. So, it's not excluding it just because it's any particular vendor. I mean, you could use the vendor certificate to exclude it, but automatically it assumes that the device is okay to even attempt provisioning. And that the device is going to be put, the assumption is that it's going to be put in the right server that it's supposed to go in. All right, let's keep going.
Do we want to guarantee that the device can verify that the attester is really the one it claims to be as well, as not only on the other direction?
Yeah, I think that may be necessary, but let's get there. We have to convince ourselves of that.
Okay.
All right. It's easier to critique something, right, than to come up with it whole cloth. So, all right. So this protocol it's got 4 steps. First of all, the client, so in our case, the device submits this is a, let's see, a push model. So the client says, I want to become registered in your system. Now that it could go either way, it could start either way, but in this particular protocol, it starts with the device. Then eventually the server, or in our case, the platform, presents a challenge to the device. The client has to respond to that challenge, and then eventually the server creates a certificate for that device, which it then keeps. So that's the big picture, right? So it's a request, a challenge, a response, and a certificate. That's the summary of it. Now you think that the simple case is, if you look at what we're trying to accomplish, we're trying to get this attestation key, public key, registered in the server. That's all we're trying to do. And we want to have the certificate come back to the client. And that's the end result. So why do we need all these steps? Why does it have to be so complicated? Particularly when you look at the last protocol, the USB 3 protocol. And, that one's way simpler. It's, here's my public key, give me a certificate, good, I'm done. So let's go through why this is so complicated. I mean, it's not that awful complicated, but it's why it's not so straightforward.
Well, this includes initial provisioning, right? Or if you want to call it ownership, exchange of ownership. Whereas the other protocol is just about really session authentication.
Yeah, I mean,
this includes the return of a certificate, essentially, for future authentication.
Yes, exactly. It's a certificate for future authentication. Exactly. All right, let's keep going. Now, I didn't go, and I'm sorry I switched up on you. I did blue as far as I could, but then it just got too messy to try to switch everything to our terms of device and so forth. So bear with me with the TPM terminology here. All right, so we're going back here. We're way over here at the very beginning, where the client, these steps here, getting over to the server. Okay, so step 1 is the client asks the TPM, create me a storage root key, if it doesn't already exist. And then the TPM, it generates a key pair. Okay. This protocol, by the way, takes advantage of some of the restrictive nature of the TPM in that, so step 3 here says it creates an attestation signing key. The TPM enforces whether things are encryption keys, signing keys, and even what kind of signing keys they are. You'll see that later. But in any case, the client says, okay, I need an attestation key, and encrypt it with that storage root key, which was the very beginning, the one that was created. Then the client says, go find the endorsement key, which is the TPM vendor, or in our case, the device vendor, right? The TPM vendor initially provisioned this TPM with an endorsement key that says, yea, verily, I built this TPM. Here's a certificate saying I did so, and it's stored there in the TPM. So the client goes and gets that out of the TPM, and then it builds a request to the server that says, here's, I want to do an enrollment. Here's my name. The host name is the client's name. Here's the certificate that came from the TPM vendor, the EK certificate that says, yea, verily, this is a real TPM. And then the public part of the attestation key, which was created up here, and it sends all that to the server. So let's go back to our diagram for a minute. So the client said, create me an attestation key, and the TPM sent back, here's the certificate for it, here's the certificate saying I'm a real TPM, and here's the key you asked for. The client sends all of that on to the server along with the client's name. All right, and then we go over to the server. Everybody with me?
Mm-hmm.
Yeah. All right, let's go on to the server. It gets more complicated. All right, so I really have to thank my colleague Ken for going through this, but Ken is a very, very practical guy, and he doesn't just put the protocol, he puts why. Why are you doing this? So the server gets what the client just sent, and the client is saying, yea, verily, this certificate is coming from a real TPM, but the server doesn't trust him because it could be an imposter, right? It could be a software imposter. Server doesn't trust anything about the client. And this is when we get into the world of remoteness, right? Because you can't trust anything that it's not inside of your own server, right? So, all right. So now the server is, remember, it's trying to record all of its devices or all of its clients. It's going to keep a record of the public keys it has seen, or the certificates in this case that it has seen, so that later when it gets attestations from that client, it knows that it's already been, it knows it's public key and it's easy to verify the attestations. All right, so first of all, since it's trying to record these, it says, did I already see this one? And if it already saw it, well, then it just doesn't have to do all this stuff. If it has not seen it before, now it says, okay, I don't trust this guy as far as I can throw him, so I'm going to see if that EK came from a real TPM or not. So that's easy to do because it knows it's the TPM vendors in advance, and it knows the root keys for those EKs from the CAs of those TPM vendors. So it then checks. Now, at this point, if it does verify, all it knows is that it came from any authentic TPM, but it doesn't know that it came from the TPM that's trying to enroll. It could be coming from a TPM off on the internet somewhere, right? We don't know which one it is. It's just that by verifying the EK, it says, yea, verily, this is an Infineon TPM or a whatever. So now it says, okay, I'm going to go further. It pulls out the endorsement key from the endorsement key certificate because it's going to need this later, and the public key. And then it goes on to check that that attestation key. Remember when we started out, it got an attestation key as part of this request. So now it wants to see that attestation key's properties, right? And these properties, that's what I was talking about earlier, that the TPM has restrictions on keys. You just can't use any old key willy-nilly to do any kind of operation. So in this case, the attestation key was actually generated on a TPM. The private half can't be duplicated. It can't leave the TPM. And it can only sign TPM generated data. It can't sign arbitrary data. It's restricted to what the TPM generates, like a quote. Let's see. Yeah, oh, and then it's algorithms and the other restrictions on it. Okay. Okay, let's see. Right. So at this point, we know that it came from a TPM, but we don't know that it came from the client's TPM. It still could have gotten this from any arbitrary TPM out there in the universe. So now the server generates a challenge, a random number, and it uses, let's see. Oh, this step I'm not familiar with. I don't know. It's I don't know what it means to using the TPM to calculate the name. Anybody know what that is? Well, anyway, okay. So it's going to pull out this public attestation key again.
The name just sort of the public properties of the key, and I think it includes the public key of the TPM, so that it's off the public part of the key, so that it's distinguished from other sort of entities. Because in TPM2, the name is used to reference the key.
Okay.
But one thing I wanted to say is that you mentioned that that you don't know that the client is on the internet. Actually, if you go through this whole protocol, you'll find that you still don't know if the TPM is actually on the internet. What all of that sort of back and forth with the TPM tells you is that it's not a sort of a simulated TPM, that it is a real TPM because you have the manufacturer's certificate in it, and it's basically that the device that you're talking to actually holds the key, the attestation key that you've generated is bound to that same TPM that you got the endorsement key for.
Yes.
So none of this tells you actually that the device is not on the internet. And you can construct an attack through all of this where you could have your TPM be just a proxy to another TPM on the internet, and all of it would work. The only way that you can solve that problem that I'm able to think of is you need mutual auth between the TPM and the server, which poses its own set of challenges because then you're effectively binding that TPM to that attester.
Right. Yep. Yep. All right. So let's keep going. And we'll see how that is true, because we'll see that through the remainder of this protocol. All right. So the hang on, I lost my train of thought. Okay, so it now gets the public attestation key, the one that was sent along with the request, and now the server says, okay, I know which TPM it's supposed to be going to because I have this endorsement key, public key. it pulled it out of the certificate that it's already validated, that it came from a real TPM vendor. And then it runs this TPM2 make credential because it's trying to force this credential. Well, here it says here, it links the challenge that it got, the attestation key, and it encrypts it with the endorsement key, public key, so that when it gets returned to the TPM on the client, only that specific TPM can unwrap all of this. So instead of just throwing it a challenge, a random number, it's all wrapped together, encrypted with the endorsement key, public key. So that's then our challenge to the client. These steps up here, 6, 7, 8, there's no secrets in them. The reason it's done in TPM terms is that you could use a software TPM to do those steps. They're all implemented. You don't have to try to reinvent the wheel. But that's what step 9 says. It's just use a TPM or a software TPM to do those rather than write your own. Finally, the server says, okay, I'm going to store this client, the name of this client and its certificate that I got from it in my database, in my list of clients. But it still doesn't make it valid. It doesn't know whether it came from the client's TPM yet, because it hasn't gotten a response to the challenge yet. This, by the way, one of our cryptographers, Hugo Krautchik, added this step in the protocol. So step 11 says, okay, now take all of this thing that I put together in all those steps and now send it to the client. All right, and what it's sending is this enrollment request, a credential blob, because it had to build all that through those steps, and then this secret challenge, which the client has to be the original client to be able to unwrap. So let's go back up to our chart here, our diagram. All right, so all of those steps have been that we received this request, we validated that it came from a real TPM, we checked the certificate or key properties to make sure it was being used, the right kind of key, we generated an answer, a challenge, we created a credential that the TPM will be able to unwrap, and it's all wrapped up in the endorsement key that is only existing on that TPM. We send it off, and that's where we are now. So we've been through this part of the diagram. Questions so far?
No, I think it's all good.
All right, so let's go back to the second client. So we did the client request, we did the server's challenge, which was rather complicated. It gets easier from here. All right, and then the client response. So now the client gets the challenge, and this is only, sometimes the EK is not kept always on the TPM. Sometimes it has to be recreated using the, oh gosh, what am I trying to think of? Anyway, sometimes it has to be recreated, but if need be, it'll recreate the EK. Okay, then it also, it had an attestation key that it created, remember in the earlier steps, so it's got to load that if it's not still in the TPM. All right, and now the server has sent it a credential, right? So the client says, okay, I want to activate that credential. It's using all of that stuff that came from the server, the blob, the encrypted secret, the handle to the EK, and the handle to the attestation key. I don't know what this is about the policy session. Anybody have an idea? No, I could ask Ken. But it's important, but I don't think we have to go into that detail now. It's a TPM thing. All right, now we rely on the trustworthiness of the TPM because we know it's a real TPM, and only a real TPM can validate this, because remember, it was all wrapped with the EK, and the EK is from this TPM. And
Elaine,
yes,
all that's basically saying is that you need a secret in order to be able to use the EK. It's
okay.
the equivalent of the owner password. So each key, when you create it, you can specify what is the policy for using that key. And typically for the EK, you need, I think, the platform owner's password or something to be able to use it. And so you create
Okay.
a policy session. Effectively, you're just like, you need some password to be able to use the EK.
Got it. Okay. Yeah, or
And
some,
this
yeah.
addresses what I asked earlier about how the device knows that the tester is indeed the right one. It has to know the password.
Well,
Yeah, it's kind of interesting because the password, the person who uses the TPM, it's really they know the password, but those passwords, unless you provision each TPM with a unique password, I don't know how secure those passwords end up being.
It makes sense, yeah.
Right,
Okay.
because now if you have like every device has a TPM like capability, I don't know how well it will. Anyway, that's sort of a separate issue.
It's,
yeah.
it's the provision that's there, but I don't think it's widely used as unique provisioning like that.
Yeah, I don't think this password has anything to do with authenticating the server at all. It's just that it has to be satisfied in some way,
Kind
either
of role check or whatever. Okay.
So I think when you're using the TPM, so I think this is more programmatically actually is there. So if you program for the TPM and after some use, if you don't go and set your policy, you won't be able to use some keys or some other sessions. So literally, this is just to press a button. I'm allowed to use the EK now.
Yeah, it's basically, I think you've all said, it's like a role separation. I think there's three roles there, or three hierarchies: a platform hierarchy, an endorsement hierarchy, and a storage hierarchy. And then there's different roles that are supposed to be there for the person who creates the platform and the person who's currently using the platform. And then things like the EK are, controlled by the platform, envisioned as being controlled by the platform owner. And things like the attestation key could be, generated by the platform user, or things like that. So part of it, sort of, it anticipates different usage models, which, depending on sort of the deployment context, may or may not, they may all sort of collapse into one person.
Yeah, especially in our world, I think. All right, where did we leave off? Oh, okay. So now it's the TPM doing the validating now. It's not the client. So the TPM is validating that that what was sent in this blob. I'm going to combine these two steps together, but the credential blob, that it has the authorization for it. It has the that everything associated with this credential blob can truly be validated, that it's trying to create this credential, and the TPM says, no, I'm not creating this credential, not until you can prove to me that you satisfy all the conditions for doing so. It's the right kind of key, it's the right name, and everything else. And it can even decrypt it, because remember, it's encrypted by the server in this case. So it's got to be able to decrypt it as well. All right, so let's see, this check, I'm on step 6 now. This check prevents the client from sending an attestation key to the server that's different from the one generated by the TPM, because it's the TPM that generated the attestation key, not the client. So the TPM says, you better give me back, use my attestation key. You've got to prove to me that that's the one that you want me to create the credential for. Okay, so then it uses, step 7, it uses its EK private key that only the TPM has. Right? And finally, so it's now unwrapped the it's unwrapped the key, it's unwrapped this blob, verified everything about it, and it has now then created a certificate. Yes, it's created a certificate that it's going to send back to the server. Let me go back up here to our diagram. Nope, it hasn't done the certificate yet. Hang on. Right. So our server said, go create, hang on. I'll get myself caught in a loop here. Oh, yeah, the create EKA is because it has to do it again if it hasn't been created. Right. This step, the client said, activate my credential, unwrap it. There's a step missing here, which is to give back the challenge from the TPM to the client. And then the client says, okay, I've been able to decrypt your challenge, server. So now I can show you that everything that you asked me to do was unwrapped by a real TPM, because otherwise it could not have unwrapped it, right? So I'm answering your challenge now because it unwrapped, it decrypted that blob and pulled out from it a challenge. But it wasn't just decrypting it, it was checking all kinds of other things at the same time, which is part of the activate credential. All right. Still with me?
Yep.
Trying to.
So that challenge, the challenge arrow going to the right is a challenge response, right?
Yes, you're right. It's a challenge response. That's bad. It's wrong there. It should say challenge response.
Because as I read it, it's kind of an encrypted challenge being sent, and the decrypted challenge is being sent back.
Yes.
Yeah. So the TPM has a certificate, a manufacturer certificate. You challenge it, you tell it to create you a certificate, and it's essentially at that stage it's endorsed. I guess it's endorsed by the TPM manufacturer certificate, and then you give it a challenge. You go back and forth a little bit, but then it eventually comes out, responds to your challenge, and then you give it back a attestation certificate that is signed by you and that you trust.
Yep.
And that's the final steps here. So right now, you're all of this is the build up to challenging the device to provide it a certificate to use for future attestation.
I mean, is this a TCG standard, or is this something that IBM, created, used based on, the TCG technologies, or is this actually, like an established standard of some kind?
So this is, as part of TCG, there are all kinds of documents that explain how to use it. So the standard is all of these individual arrows by themselves, like what is the activate credential and what's a make credential. But how to glue all the pieces together is not part of the standard.
Okay, that's what I wanted to know. All right.
This is a tutorial on how to use it. All right, so the last step is the easiest, finally. Okay, so now the server now says, well, I sent that challenge off, but now I want to make sure that it's the same one that came back, right? The fact that it's even come back at all and it's the same proves that the client was able to decrypt the challenge. And it could only encrypt it if it really had the EK private key. And the EK private key we know is from an authentic TPM. And that the attestation key had the right kind of properties, because you don't want it to be using willy-nilly keys that, you know, are meant for data encryption and such. Okay. Let's see. Read that sentence. The match is important. It is not enough to detect a valid attestation public key, since the client could try to install a counterfeit, right? Because if this were like totally software, for example, then you can't just say, hey, I take your public key and I validated it. You have to make sure it came from a real TPM and that it's the right kind of key and so forth. All right, so finally.
I have one question. When you mean real TPM?
A real hardware TPM in this case.
Yeah, when you mean real hardware TPM, so this way works only with the discrete TPMs, right? Because on your diagram, you show the what it verifies, what the I think it's EK certificate belongs to the real TPM.
Let me get up to the diagram. This one? Yes.
Okay, so validate EK certificate.
Yeah, so the TPM vendor created that and put it on.
Sends the data to the server, client sends the data to the server. It says validate EK certificate first. Okay, so, and by that, as I understand from your explanation, it understands what there is the real TPM behind it.
Right, the server knows.
So my question is, there are cases when people using firmware TPM, which is not actually real hardware, but it runs the like a TPM firmware in some virtual space. So yeah. What's going to happen in this case?
So it would go through the same protocol, but the server then would know what the root CA is for that firmware TPM. And it would have to decide whether it likes that or not. Does it want to talk to a firmware TPM or a hardware one? But it would know what the root CA is for that certificate. Mm-hmm. It has to. In fact, that was when we started at the beginning. It said the root of trust for this really is anchored in the CAs and the root certificates from the vendors.
So when you have like a FTPM, you will need to have a certificate which is known by the server to understand what your FTPM is. It's real TPM. I mean, it's not real TPM, but it's a functional TPM which is run on the client.
You would still need that to be able to validate who made it, who instantiated it would be another way to view it.
Yeah, I think the hardware and the firmware TPM, you can probably think of them as the same thing. It's really a implementation-based thing. I think for the firmware TPM, you do have the challenges of being able to protect the private keys that are inside the TPM, and how you achieve that. There's different implementations for that, but you know, usually a hardware TPM is going to take care of that. It has a secure element, secure storage. for the keys that it generates. When you go to the FTPM and it's in firmware, do you have a secure element to keep those public keys or those private keys? Sorry.
Yeah, that's exactly right. All right. Where did we get to down here? I think we were almost done. We're almost running out of time too. Okay, right. So now this is when step 2 is when the server says, okay, you've convinced me now. I'm going to generate a certificate for you and sign it. And the server signs this certificate. It records it on itself, so it will know later when it recognizes something coming from there, and it sends it to the client. And yeah, so if we go back to our diagram, the server has been finally convinced. It got the public key that belongs to that particular client and the name of the client. It generates the certificate. It sends it to the client. There's a step missing here too. This has to go down into the TPM, I think, also. But all right. So there's also one observation that Ken noted. He said, which is in this, sorry, I'm scrolling so fast here, the epilogue. He said, we're really trying to get public keys, right? We want to, the goal of all this is that the server got a public key from the client. We went through all of that rigmarole so that the server could just get one dang private public key from the client. So why didn't it just store a raw key? Well, really, it's a convenience factor, because on either side, there are lots of tools for parsing and verifying X509 DER encoded certificates. So rather than storing it as a raw key, it's just a convenience factor to store it as a certificate instead. And then you can also use it to certify other TPM keys and chain those based on that key. So anyway, that is it. So I don't know if anybody has been convinced that we need this level of detail and complexity, but I think just having been through this, it convinces me that there's more to it than just sending over a public key.
In what way?
Well, you want to know.
And you mean versus the USB protocol?
Well, the USB protocol assumes that the keys are already provisioned in there. There isn't actual. Yeah. That's like the USB protocol describes a authentication flow that doesn't result in keys changing. So it assumes that the keys or that the certificates changing. It assumes that the certificates are already provisioned in the device. The TPM flow has, if you want to call it a take ownership.
TPM flow was created. TPM flow was created before devices had their own root of trust and storage for keys, right? So that's kind of why TPM kind of takes that thing for the devices.
Well, the TPM comes up with its manufacturer. It's all endorsed by the manufacturing key. So whoever manufactures a TPM has their, if you want to call it, CA key inside their public key that is going to, when they generate a certificate, when you challenge the device, you get back that key and you know it's a genuine part, right? Because it's got the manufacturer's key inside it. So you know it's a genuine part from that TPM manufacturer. And then you tell it to go and generate some attestation keys, and then you do a challenge. Once you get back this endorsement certificate and attestation key, you walk through a challenge, which eventually culminates in you signing
the attestation key, or the attestation, generating a certificate and essentially signing the attestation key or authorizing the attestation key and providing it back to the TPM, and then using that certificate from that point forward.
But the TPM flow doesn't really tell you anything about the if we put a equal sign on the client equals the device. It doesn't really tell us anything about the authenticity of the device before this provisioning.
Yeah, yes, you have to go back to the manufacturer's certificate for that authenticity.
But it's the TPM manufacturer, not the device manufacturer. It doesn't really tell you anything about the device.
Right. So in this case, the question is, to me, is how does this fit in our model? When we have devices that are showing up in a system, then how do we believe that they're really from the vendor that says they're from? How do we trust them? Why are we going to trust their attestations that they send us? We've got to get their keys. And why do we trust the keys they give us?
Are there other, so these are two protocols we've reviewed here. I mean, are there other example protocols that, we should also look at? I mean, that would help answer it. Like, I don't know, with Cerberus, Brian, I mean, you have a different protocol of some kind. I guess it's not for enrollment, I don't think, but do you think that's relevant to kind of compare, with what we're looking at here?
Yeah, for enrollment, we do a very different thing. But with Cerberus, for session authentication, we use a flow similar to the USB authentication flow. For certificate enrollment, we do something very different.
Is it something public that you can share, or is it documented?
I do have a document on it, but it essentially is a little bit more intrusive in that we provision the device with one of our keys, the initial certificate. So this device, when a TPM comes, it comes with a manufacturer certificate, and then you tell it, hey, generate me a certificate, but you're trusting that manufacturer certificate. So you initially establish that this is a genuine TPM by trusting the certificate of the TPM manufacturer, right? And then after that, you use that manufacturer certificate to do some exchange of information and eventually send it your own attestation certificate. In the model we use, we provision the devices with our own certificate from Girth. So the challenge we have with the TPM key is we have to trust the integrity of the manufacturer certificate, which is fine in a lot of cases, but in certain cases where maybe we're a bit more paranoid about security, we don't want to trust the integrity of that manufacturer certificate. So we use our own certificate, and we intersect ourselves in the manufacturing pipeline. But that's it's a heavy-handed approach, I would assume for most. So I think something with provisioning of certificates along these lines is good, and certificate initial provisioning and future authentication after that point of provisioning are separate flows.
Yes.
Right. So once you've provisioned this TPM, you can authenticate with it in different ways. Every time you will establish a session with it, you wouldn't go through all of this flow in generating a new certificate for that session. Actually, with the ECDHA, we do generate keys, temporal keys for that session,
but that's just part of that key exchange protocol.
Well, we're over time, way over
I
time.
could bring next week, because I can maybe bring next week a how we want to do ownership kind of endorsement with PCIe protocol, which is based on the USB. Maybe that's going to be useful as well.
Yes, that again is doing authentication, right? So
it's doing so no, that assumes that there's certificates and keys provision in the device by manufacturing, but we also are thinking about the flow that will allow the owner of the device to provision a ownership certificate that they can use for authentication instead of using the vendor certificate.
Oh, okay, that will be good.
We'll be skipping next week, right?
Sorry?
We're skipping next week, right? Because Brian and Nate and I are all away.
Okay.
Some of us
So
are
in 2 weeks, I guess.
Yeah.
The 4th,
yeah.
Right?
Yeah, one thing I think could be helpful as we go through these different mechanisms, that we kind of stay focused. My concern is me personally will get lost as we go. Here's what we're going to do for provisioning versus here's what we're doing for attestation versus, so we don't mix the protocols and the procedures between the two. That's all. So if we're going to focus on, I think it sounds like on the provisioning part first, that's great, right? Then we can compare this to, the USB solution that's going to be proposed in 2 weeks, and blah blah blah. If we can do that, that would be helpful.
Yeah, sounds good.
Okay. All right. Thanks a lot, Lane, for this. This has been good. And then maybe when we resume on the 4th, we'll go through the other proposal for the USB and key exchange that was in mind.
Yeah, at least we can try to figure out what model fits what we're trying to accomplish.
Yeah. But this is good. So Elaine, is this, I know you have some comments in this one. Is this document public or you put this out on Google Docs already?
I put it in Google Docs, but I don't know how to share it with everybody. So Nate is going to help me do that.
Oh, cool. Yeah, he's good with us.
Because I don't have the list of everybody to share it with.
Yeah,
Okay.
I sent you directions for how to make it viewable by anyone with the link.
Oh, thank you, Nate. I will do that.
All right. Okay. Well, then I guess we'll convene on the 4th.
Right. Thanks, everybody.
Thanks a lot.
Thank you.
Have a good day.
Bye.
Bye.